Okay, so in this video, again, we're actually just revising things that technically could have come up at junior cert level. We're simply going to manipulate formula. So the first example here, we're talking about, I want you to make g the subject of the equation. And you're told that t is equal to 2 pi times the square root of L over g. To make g the subject of the equation simply means get g on its own. At the moment, t is the subject of the equation. T equals whatever. So now I just need to manipulate it around so I have g on its own. With each line in a question like this, you just have to ask yourself, what is the immediate complication? There's not always just one size fits all for this. There's a couple of different ways of doing it. But for me here, the biggest complication is the presence of the square root. In order to eliminate a square root, you need to square it. If I square a square root, it'll be gone. If I want to square this to eliminate the square root, I have to square everything. So t to be squared will just become t squared. 2 pi multiplied by 2 pi would become 4 pi squared. The square root of L over g to be squared will simply become L over g. And now I could view this a different way. So the way I have this is 4 pi squared multiplied by L over g. But you need to realize that another way of writing that is simply 4 pi squared L and the whole thing is over g. That's the same thing. If I write it like that, it's the same thing. And in the context of what we're trying to do, it's probably easier to just view it like that. Now I would say that my immediate complication is the presence of a fraction. In order to eliminate the fraction, I'm going to multiply by the denominator. If I multiply the right hand side by g, I'll simply be left with 4 pi squared L. If I multiply the left hand side by g, I'll be left with t squared times g. Now I've got no immediate complications, it's quite straightforward. Now I'll look at the question. It asks me to make g the subject of the equation, so I just need to eliminate the t squared from the left hand side. And in order to do that, I'm going to divide both sides by t squared. If I divide the left hand side by t squared, I'm going to get g. If I divide the right hand side by t squared, I get 4 pi squared L divided by t squared. And now I've manipulated my equation so that g is the subject of the equation. So that's the only example I'm going to do. I'm just going to give you three or four equations that I want you to manipulate in this video. Okay, so I've written out 3 questions here. Question 1 and question 3 are very similar to that example I did, and question 2 is just slightly different. The first one, I want you to make h the subject of the equation v is equal to 1/3 pi r squared h. The second one, I'm telling you that x is root a plus 1 over root a, while y is root a minus 1 over root a. I'm telling you that a is greater than 0 just simply because if it's in a surd, I need the square root of a positive number rather than the square root of a negative number. And once you have x and y, I want you to find the value of the square root of x squared minus y squared. And in question 3, I'm asking you to make or the subject of the equation, where z is equal to the square root of k times r cubed divided by 1 minus m. So I want you to pause the video and I want you to try these 3 questions and then just compare it to my solutions. So I think these ones are straightforward enough. The first question, you needed to make h the subject of the equation, v equals 1/3 pi r squared h. 1/3 pi r squared h can be written as pi r squared h over 3. It's the same thing. It's easier to view it like this in the context of what we're trying to do. I multiplied by 3 to eliminate my fraction and then divided both sides by pi r squared in order to isolate h. So in that case, you should have had 3v over pi r squared equals h. Okay, the second question was a little bit different. There are a number of different ways of doing it, but I think the way that I've done it out here is probably the most straightforward. X is root a plus 1 over root a, while y is root a minus 1 over root a. And we were asked to get the square root of x squared minus y squared. The easiest thing to do here is to factorize. X squared minus y squared is the difference of 2 squares. So I can write that as x minus y times x plus y. And at that stage then I just subbed in. X is root a plus 1 over root a. And now it's minus y, which means I need to change the signs. So it's minus root a plus 1 over root a. And then in x minus y, root a minus root a will cancel. You've 1 over root a plus 1 over root a, which is 2 over root a. The bracket on the right hand side was x plus y, where I literally just wrote out x and I wrote out y. And in this case, the fractions cancel, and I'm left with root a plus root a, which is 2 root a. So now I just have the square root of 2 over root a multiplied by 2 root a. So in this case, there's a root a on the bottom, which divides into the root a on the top, and I'm actually just left with 2 times 2, which is 4. So the square root of 4, my final answer works out as 2. Okay, in the third question here, we had z equals the square root of kr cubed over 1 minus m. And I asked you to make or the subject of the equation. The first thing I've done here is I've squared both sides in order to eliminate the square root. So the left hand side becomes z squared, and the right hand side the square root is gone. Then I decided to try and eliminate my fraction. In order to eliminate the fraction, you multiply by the denominator, which is 1 minus m. When you multiply the right hand side by 1 minus m, the fraction is gone, and the left hand side becomes z squared times 1 minus m. I then decided to isolate my or on the right hand side of the equation. So I have to divide both sides by k in order to get or cubed on its own. So I have z squared over z squared times 1 minus m divided by k is equal to or cubed. And then in order to eliminate the cubed on the right hand side, I got the cubic root of both sides. The cubic root of or cubed is just or. The cubic root of the left hand side, I just write it as a cubic root. So ultimately your answer here is that or is equal to the cubic root of z squared times 1 minus m over k. So I've manipulated it round so or is the subject of the equation. It's just important that you're very comfortable with that kind of thing, because no matter what we do in the Leaving Cert Higher Level Maths course, you're often required to manipulate equations around and try and make one thing the subject or another thing the subject of an equation.